Good day, Professor Breaker here at New Mexico State University. In this video, we're going to run through Docs Lab 2. Basically, we're going to create an image. Before we start creating any images or doing anything, we're going to clean up our environment. We're going to run this command, remove any previous Docker containers and remove any previous Docker images. You should know what those commands do by now, but let's go ahead and make sure that we've run those. And you can see that there's no containers and no images listed. So let's go ahead and get started on our container images. Now we're going to use an existing container, basically the default basic Ubuntu container. We're going to make some changes to it, and then we're going to take that container that we make changes to, and we're going to create an image out of it. So let's go ahead and get the container up and running. And in this command here, we want to start up the container. We want to go into interactive mode and open up a bash command prompt or command shell. So that's how we do that. Basically, it says there is no Ubuntu image available, so it's going to download the Ubuntu image. We're going to use that image for the container to build our container. It's 27 megabytes, nothing like the size of a virtual machine file. So we can start up that container. Again, we're running this on a CentOS Linux operating system, so we can run an Ubuntu container, or actually we can run most any containers on any computer that we have Docker installed on, which makes it pretty cool. We can run snippets of code, and they're great for microservices. If we have a specialty application we want to run, we don't need a full operating system. We just need the files and the utilities that are needed for that specific operation. So if we do a host name, we can see we have this random character string, which shows that we are actually in the shell. If we can now start doing apt-get. Now, normally on a Red Hat system, you'd use yum or DNF. Because this is an Ubuntu system that we're into, we can use the Debian-based package commands. So let's run updates. Now you'll notice that run updates aren't nearly as much on a container as they are on a virtual machine. And that's simply because this container basically has only what's needed to run this Ubuntu container. After we run the updates, if you look at the commands that we're going to be doing, we're going to install a little program called Figlet. Now, we're just doing this as an example. We might want to install WordPress or install Apache with WordPress or NGIX with WordPress or something like that. Like we actually used the WordPress container, had all that installed. We're going to install the Figlet package. You notice we're using normal commands we'd use for an Ubuntu machine if we were logged into Ubuntu. And then we can use the Figlet. And Figlet is just a little program that puts out something like it puts it out in blocks. You pass it a text and it puts it out in blocks. So that's what our container does. It's a simple container that has Figlet installed in it. Not much else. It's been updated. We're good to go. Let's go ahead and exit this. Now once we exit, we'll notice that container no longer is running. It's there, and we can see that by doing -A, which shows us there is a container named Figlet, but it's not there. We can also look at the differences. So if we do we can see what the difference is between the container, and we're going to use a container ID, which is 833CD. We can see that right over here, 833CD. And actually, I usually use just the first four characters. 883C. And that's going to tell us this is what was all done on that container, which is different from the image. So it's doing a comparison, container, image, here's the things that are done. These files are different, okay? So we know these files are different. we can scroll down here. Let's again follow along with our instructions over here. And so we did a container ls-a. We saw that the container is there. Let's go ahead and do a container commit. And here's we're going to give it a container ID. So to create an image, we need to commit this container. Let's go ahead and move this over so we can read a little bit better. The commit creates an image locally on the system running the Docker engine. Run the following command using the container ID you retrieved. In order to commit the container, create an image out of it. So let's go ahead and do that. So let's go ahead and say container, oops. Oh, let's do container ls again. We can either do Docker container ls or Docker ps-a. Sorry. Okay, there's our container name is 883c. So we can go Docker (883c). Okay, now that makes an image out of it. You can see we have Ubuntu, and then we have an image that's not tagged. Okay, so we need to tag this image. And so let's put a tag on it. Oops. Now the image ID is 373, and I'm going to use 373D. And then let's give it a name here. We're going to use our full name. In this case, my alias is James Smith. So now if we do Docker, we can see we have an image named James Smith. And now if we want to run that, we can run our image, and they have the example of it here. Let's go back over to here. You can see their images. And now we can say Docker container run. But this time we're just going to pass it commands. Now before we pass it the command to run bash interactively, now we could tell it to run figlater interactively, but we don't need to. We can just say Docker run, give it the name of our container, and pass it the commands we want to run. In this case, we're going to run the command figlet. All right. And there's our hello. I think you have something different you have to do for the assignment, but that's going to be pretty close to what you have to do for the assignment. And that's the first part of just, we created a simple container. Now, if we wanted to run a different command, we could actually run a different command against that container. Okay, and so right now there's just the ps command. We can ps, and there's all the processes that are running on that container, which right now there's no processes running, or just the root process running. There we go. We can pass commands directly into containers when we create them. Now if we do a Docker container, Docker ps -a, you can see that we created, now notice if you look at, we sent commands to them and it created multiple containers. Okay, so every time we ran a command that we said Docker run container, it created a new container, ran the command, and because that's all we wanted to do, it exited out of it. And this is a case where you could pile up tons of containers, and this is where you might want to run that command Docker rm, that's remove, basically remove, and then we're going to do $, Docker ps-aq, and that's going to remove all our containers. See, it's pulled all those containers IDs. And now if we do a Docker -A. You can see we know we've cleaned up all our containers, got rid of all those containers. We can still run the container because we still have the image. Remember, it grabs the image, builds the container, runs the command, and then exits. So we can still look at our images. Oh, images. And there's our images. We still have our image, so we could still run the command again. It'll just take the image, create a new container, run the command, put the output from the figlet if we want to do that, and then close and turn off or exit the container, and the container will be there. We can actually run the container, so let's go ahead and run that command again. Let's go ahead and run and create a container, and let's do the figlet hello. Let's do the 463 command again, just so it puts it out, and so it can run that container. There we go with the container. If we do you can see the container is there, but it's not running. We can start it again. And the name of the container is A488 because the container is all unique. And we can see that the, oops. It started, it had exited. So there we go. We can go ahead and exit out of there or clean that container up and delete it, but that gives you the idea of creating a container right from the command prompt. Now, in our instructions here, the next set on our instructions is going to move to creating a image using a Docker file. Okay, so the first thing we did was we created an image. We basically created an image from a container. We created the container first. Now we're going to create an image using a Docker file. So that's the next step in this lab here. If you scroll down here, you're going to see image creation using a Docker file that directly lines up with number 2. So then you'll be following the instructions in this part. Now that you know a little bit about images, now we're going to talk about creating Docker files. And Docker files are basically files that tell the image what to do and what we're going to do. So follow the instructions here and create this. We're going to use Alpine. We're going to run these commands against it. We're going to copy a local file or folder, actually a local file, which is going to be this one here, into the app folder on the image. We're going to set the working directory to be the app folder, and then basically we're running the command node and index.js, which is the file that we create up here. And that tells it to run the command node, passing it the node is basically node.js, passing it the file name that we want it to run, and then when we build our image, it should run a little web page for us. Okay, follow the instructions on there. See how good you do. Again, I'm not going to walk you through everything, but I want you to get you a good start on understanding creating images and then being able to run containers from images. And we can create images directly from a container, and we can create images from a Docker file. Have fun with this.